Hi, welcome to the Shiko Math Practice Lab, learning through practicing. And in this unit is limits units. And we are trying to practice all the different ways to find the limits. And this is our practice number 9. We're going to take a look, how do we find the limits when the x approach to infinity? And that's what we call the horizontal asymptotes. How do we find that? So if you kind of refresh the memory, so in this unit, so we have covered the previous 8 topics. So right now we're doing the topic number 9, limits at the infinity and the horizontal asymptote. Okay, let's go ahead to go to our worksheets and let's go ahead and start here. Okay, so in here, so let's take a look. For the problems here, when one they give you the graph, is really pretty easy. See here. So let's say find the function and whose graph is given below. So first one you say the x approach to infinities, right? So x approach to infinity, that means the x is go this direction. So when the x approach to infinity, so you see this function, the red one, is go to where? Yeah, it's going to very close to what? Close to 2. Okay, then the part B, the x go to the negative infinity. So here is your function going to go to, right? So here is your function going to go to here. So where is this function going to go to? What is going to approach to? This one is going to approach to the negative 1. Okay, now let's take a look at when x approach to 0. 0 is here. That means you're going to approach this way and this way, right? So what is your function limits going to both approach to? This one going to approach to the negative infinity. Okay, so now the next thing is here. Let's take a look here. So if the x approach to 2 from the left-hand side, so this is 2, right? If from the left-hand side, that means I'm approaching to here. Remember, you kind of then trace your curve. So what is the value you're going to approach to? I'm going to approach to the negative infinities, right? Okay, so the same way here, let's take a look. If the x approach to 2 from the from the right-hand side. So this is 2. So if you approach to 2 from the right-hand side, so you still, like you trace your function. So from here, where is your function? Hey, here's your functions, right? So this one's here going to the infinity. So now in here we see we have some horizontal infinity, we have some vertical infinity. So let's write it. So the horizontal infinity is what? Is where the y values, right? So this is one of the horizontal infinity, and this is right the horizontal, asymptote. So I know the y equal to 2 and the y equal to the negative 1. Those are the horizontal asymptote. So what is the vertical asymptote? So the vertical asymptote will be, the x, like this one and this one, right? So will be x equal to what? X equal to 0 and x equal to what? X equal to 2, right? So the problem number 3, this problem is just similar, like this problem you just see when they approach to, now what is your function going to, right? Okay, so now let's see the limits show what limit is, find the limit and show where it does not exist. Before we do this, let me do a little brief review and so kind of refresh your memories here. So if you remember, we said when the limit x approach to infinities, right? So if your function is like a 2, like a px, qx, if they are both of these two, if they are polynomial, so you can approach to positive infinity or negative infinity, doesn't matter. So if here this is an xn plus an minus 1 x And so this is xn minus 1. So here should be xn to the power, then plus da 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 plus a1x plus a0. So here you have bn xn plus bn minus 1, xn minus 1 plus b1 x plus b0, right? So remember during the lecture we talk about, so for the polynomial we just compare which one go faster, right? So we're looking for the exponents here. Okay, so here is the exponents, and here are the constants in front of this exponent. So we know, so here we have three cases here, right? So we say if the limit x approach to infinity, so let's see here, okay, let's do this. So we say if n greater than m, that means my top is go faster, right? So if top is go faster, and so the whole limit here, x approach to infinity, and then this px, qx will be equal to what? Will be equal to infinities, right? So we say if they are the same exponents, that means they are running at the same speed, then we say limit x approach to infinity, the px, qx will be equal to what? Will just be equal to the constants in front of them, correct? And then if n is less than n, that means the denominator approach a lot faster, right? So limit x approach to infinity, then the px, qx, because the denominator is a lot faster. So what here we have? So we have here is 0, okay? And so, the real way when you try to do the problem, let me give you examples here. If you set x to the infinity, so if this is the x squared, you say 3x squared minus x plus 1. And this is 4x squared plus x minus plus 3, okay? So in here, as you can see, the exponents here are the same, right? So what we can do is we say, okay, so the typical way, the way if you really want to do mathematically, you kind of show your procedure, prove it. So you can take the x squared out. Okay, so if you take the x squared out, so here will be 3. So what is here? It will be x over x squared, right? So you will have x, then plus 1 over x squared. Then the bottom, you can take the x squared out also. So here we'll have 4 plus 1 over x and 3 over x squared, right? Now when you let the limit approach to infinity, so these two I can cancel. So here, look here, when the limit approach to infinity, these two terms going to approach to what? Approach to zeros, right? Because the denominator get bigger and bigger. So that's why the final answer is 3 over 4. So when you do the problem, you can do this way, or you can just directly identify the powers, right? The exponents, and then you decide which cases is your cases here. Okay, now let's go back to our, our lecture notes here. All right, so now let's take a look here. All right, so here, okay, let's see here. So the first one here, this is a 2x squared, 5x squared. So as you can see, what is the highest powers here is x squared, x squared. So what is the answer? Because it's n equal to m. So what is here is 2/5. Correct? So you can write it, so if you want, you can try to do like what we did before, you factor the x squared out. That's fine. Or you can just highlight and say, hey, this is the exponents is 2. This here is the exponents 2. Then you can say the an equal to the bn's, right? So if an n, and I'm sorry, it's not an equal to the bn, so you will say the n equal to m's, right? The exponents are the same. That's why you just compare the constant. Okay, now let's take a look here. So number 14 is here. So it says here, right? So it's inside the square roots. Okay, if inside the square roots, so if you take a look at inside square roots, the highest one is what? It's x cubed, right? So when you try to take a look here, you can say, hey, I can take the limits inside, right? So this is approach to infinity. So this is 3 minus 5x plus x cubed. And this is 9x cubed plus ax minus 4. And because you recognize they have the same side, same exponents. So what is this limit going to be equal to? Because the constants in front, right? So it's 9 over 1, so it's a 9. And what is here? It's a 3 here. All right, so it's pretty easy. Okay, so now here, the next one here is x approach to the negative infinity. Okay, if x approach to the negative infinity, then you say, here is my biggest one. So, right? So they are the same. They are both x cubed. So in fact, you can factor the x cubed out. And so then you just compare the constants in the front. So what is here is 2. Okay, now let's take a look. Number 15 is quite simple, right? Because both of this is the same power. So what is here? 3/2. Okay, now let's take a look here. Number 16 here. All right, so number 16, what is the top power? Is 2, right? So this is the top exponents is 2, n is equal to 2. And what is your denominators here? Is 3's, right? So that means your m is equal to 3. So the denominator is faster than the numerator. So what is this one? It's 0. Okay, so we just need to be very careful. Okay, now let's take a look at number 20 here, right? So let's take a look. What is the highest power on the denominator? It's 2/3, right? So n is 3/2. I'm sorry, not 2/3. Okay, now you take a look at the top here. These items here, right? So this is a t, the square roots of the t. And so this is t times, what is the square root of t? It's 1/2. So this is t to the what? It's 3/2. Oh boy, so what happens here? They are the same exponents like you have in the denominator. Okay, so what is the answer? The answer will just be the coefficients, right? So what is the coefficient? Hey, here, this is -1. What is the coefficient here? It's 2. So what is the answer? It's -1/2. It's pretty good, okay? So we're kind of getting this fast because it's kind of like a, pretty simple one. Okay, so now this is limit x approach to the infinities here, right? So x approach to the infinity, and then you take a look here. This is a 2x square. Then you squared it. I don't really need to FOIL it because I know after I FOIL it, what is the highest term? It's a 4x to the what? 4th, right? The same way is here. Look here. This is x have a square. Of course, you can FOIL it. But then if you FOIL it, you know this is x squared minus 2x plus 1, right? So then this x squared and this x squared. So what do you have here? You have x4. See that? And so this x4 and this x4 is the same level. So what is the answer here? Will just be the constant. So what is the constant? This constant is 4, this constant is 1, right? So what is the final answer? This one will be what? Will be 4 here. All right? Okay. Now let's take a look at number 22 here. Okay, so the number 22 is here. Okay, so the same way is here. This is x approach to the infinity. So this is the, okay, take a look here. This is exponents is x equal to 2. Correct? So this is x equal to 2. So n is equal to 2. And then this one's here is the x4s. Then you take the square roots. So what is this one turns out to be? X squared. Because we know the 1 doesn't matter, it's denominator, right? So n is equal to 2 also. So now the both top and the bottom have the same exponents. So what is this limit? This limit is 1. Okay, now let's take a look at this one here. Okay, so for this one, the x approach to the negative infinity, we need to be careful, right? Okay, so when x equal to the negative infinity here, take a look here. Inside here, this is 4x to the cube, the 6, right? Okay, so remember that here, so 4x to the 6. So if you take the square roots, so this is the 2x to the cube. I know when I take the square roots of a number, the result cannot be negatives, right? So I put the absolute values here, okay? So this is what I have on the top. Then what I have on the bottoms here, this is x cubed. Oh, that's good, right? So the bottoms here is a negative x cubed. So be careful here, right? So as you see here, okay, so these numbers here, okay, so they do have the same powers here. All right, be very careful. All right, but here, make sure here, you know, these things here is all what? Is all positive. Correct? And then these ones here, when the x here is in the negative infinity, so we know the negative infinity to the third power, to the odd power, you know, if your exponency is odd, so this one will give you what? This one will give you a negative. But now you have negative and negative. What you have here, you have a total is a positive. So your denominator is a positive, your numerator is positive. So what is the final answers here? The final answer is 2. Okay, so be very careful, right? Especially when x equal to the negative infinity. So this province, be very careful here. All right, so now let's take a look at this one here. All right, so let's do the same thing. And when we have the, you know, the square roots, right? So take a look here. This is x squared. Okay, the x squared, take the square roots. So what is this terms here? Will give you square roots of 3x here. So for here, I don't need to put an absolute value because why? Because my x approach to positive infinity. Okay, so now you see, oh, that's good. This x and this x has the same power. So here the n equal to 1, m equal to 1, right? So what is the limits here? The limit is the square root of the 3 over what? Over 4. Okay, so those are pretty easy. See here. Okay, so now in here you say here, what is the power here? This is the second power. So n is equal to 2. So what is m here? M is, this is the highest powers, right? So what is the m? M is 1. Oh, right now, the top is bigger than the bottom. So that means the top going to infinity a lot faster. So what is the values here? This one going to be infinities here. All right. Okay, now let's take a look at number 28. Okay, for number 28, okay, take a look here. The inside here, this is a dominant terms, right? We said that the polynomial, this is a dominant term. So that means the inside, this, when the x approach to the negative infinity, because this is x squared, right? Because this is x squared, so what happens here? Because this is x squared, so this thing is going to be the positive infinity. And then this number x equal to negative infinity. So you will have infinity minus infinity, correct? So when we have the infinity minus infinity, so remember we say, hey, for the infinity minus infinities here. So what happened here? Let me think here. I can get it, okay. Okay, get a more space here. Okay, so when the infinity minus the infinity, remember we say, hey, we don't know what is that, right? And from our previous lecture, previous practice set, we said, if you see a square roots, probably what is the method I need to use here? I probably need to use the conjugate techniques, right? Okay, so let's see here. So this is limit x approach to negative infinity. And here, this is 4x squared plus 3x plus 2x. Remember, we use the conjugate. So what you times here? You times the conjugate. So this will be the 4x squared plus 3x minus 2x. And this will be the 4x squared plus 3x minus 2x, right? So those are the conjugate. And the reason why we want to use the conjugate, because I want to use this nice formulas, right? So it's a minus b times a plus b is equal to a squared minus b squared. Then you say, okay, so now here you will have limit x approach to the negative infinity. Okay, so what happened to the bottom here? So this is 4x squared. Okay, so this is a 4x squared plus 3x minus 2x. Okay, so the top is a squared minus b squared, right? So it will be 4x squared plus 3x minus 2x squared. So far, so good? Okay. All right, so now it's good. Okay, so now let's take a look here. What happens here, right? And be careful. These two can cancel. All right, so here, this will be my limit x approach to negative infinity. So this is 3x, okay? And then here, this is the 4x squared plus 3x minus 2x. Like we said before, be careful here. This is a dominant term. So it's going to come out, right? So going to come out, the square roots will be 2. And because in here is going to approach to the negative infinity, so I know when you come out of the square roots, you cannot have a negative. So I put the x here, right? So the bottom still here, I still have this 2x. Okay, think about this 2x here. So now in here, when the x approach to infinity, what is this one approach to? This is going to be a positive, correct? And these terms here, when x approach to the negative infinity, the x term here going to be negative, but I still have a positive sign here. So this term going to place what? Positive. So the whole denominator, the infinity plus infinity, the whole denominator going to become the positive infinities, right? And the top is infinity also, but this number going to approach to what? The negative number. But look here, they all have what? They all have the first powers, right? The exponents here is 1, 1, 1. So I know what just be the coefficient in front of it. So what is my answer here? This is 2 and 2, right? So it's 2 plus 2, right? Because, these things become positive. So the answer is negative 3 over what? Over 4. be very, very careful. This is kind of very important things here, when you, especially when you talk about the negative infinities here. Okay, let's do a couple more, and then we can take a break, and then we'll be back to our second lecture and second video to finish this. Okay, so now let's take a look here. Okay, so here, well, you see here, this is x fourths. This is x cubed. So you know n equal to 4, n equal to 3. So the top bigger than bottom. So what is the limit? Half. The top going a lot faster, right? Okay, now limit, okay, 32, this is interesting, okay? So let's rewrite this one. So this is the limit e to the negative x is 1 over ex, correct? And then plus cosine 3x here, and the x approach to infinity. All right, so x approach to infinity, this number going to approach to infinity, correct? All right, if this is correct, then 1 over infinity going to approach to what? Approach to 0. Okay, now let's take a look, cosine. So when the x approach to infinity, this number will approach to infinity. And we did this in this many practice before. We said a cosine, right? If you do that, so what happens here? Cosine going to continue what? Jumping between the 1 and the negative 1. So do we have a limit here? No, do not exist. So one side it has 0 and the plus do not exist. So what is the final answer for this ones here? These ones here is do not exist, right? Why? Because, this ones here is 1 over infinity is equal to 0, but the plus this term, this part, the cosine we talked before is going to jump in upside down, right? So it does not exist. That is why, that is why we say the limit is not exist. Okay, number 30 is easy. So I guess you guys can tell me when x approach to infinity, what is this thing going to approach to infinity? So what is the things here? The whole thing going to take a look at the infinity. Okay, we have practiced a lot of problems here, right? So right now probably will be a good time to stop the video. And so we're going to, this video, we're going to stop here. And what you can do is, you can continue finish the remaining problems and then go back to our second video to check the answer. So right now, the first video should help you to go through your first part of this practice. Okay, that's it. And we'll talk to you later and try to solve the second part. Okay, bye.